everybody. You join us live at the Guiana Space Center for the launch of the next batch of 4 O3b satellites for SES, built by Thales Arianespace. And we've just heard there from the range operations manager. The countdown has been restarted. We've had a bit of an issue with the weather and high altitude winds. We had the option to launch exactly 33 minutes later, and the teams decided to take that option. It gives everybody a bit more flexibility. Over now to the CEO.
Dear customers and partners, ladies and gentlemen, Arianespace is delighted to welcome you at the Guiana Space Center for this new Soyuz mission, the first of the year with our medium-weight vehicle. In a few minutes, Soyuz will lift off to put onto orbit 4 more satellites, part of the O3b Medium Earth Orbit constellation, operated by SES Networks. The payloads have been built by our long-standing partner, Thales Arianespace. Thanks to SES, for whom we are launching for the second time this year, for their trust. Soyuz is now on the launch pad. The operations linked to the final countdown are in progress. The launch is imminent. Following liftoffs, Soyuz will head toward the east to separate the satellites 2 by 2 on a circular medium Earth orbit inclined at 0.04 degrees with respect to the equatorial plane at an altitude of 7,830 kilometers. After 3 consecutive burns of Fregat, including a long ballistic phase, 2 O3b satellites will first separate around 2 hours after liftoff. The 2 other O3b satellites will separate 22 minutes later at H0 plus 2 hours and 22 minutes, marking the end of the mission. But let's leave this launch together. Go Soyuz, go O3b, and of course, enjoy the liftoff.
And that was Stefan Israel, the CEO of Arianespace. And you can see on the top right-hand side of your screen that the countdown has now turned green again. And that was Soyuz on the pad, standing tall. And here in the Mission Control Center, we are looking at the SES teams for O3b. These guys and girls all know each other very well. Some of them have been working together for months and some of them for years. Soyuz is built in Russia and shipped here to French Guiana to be assembled. The preparation process is called the launch campaign, and it started some months ago.
The 4 O3b satellites, called respectively FM13, FM14, FM15, and FM16, arrived in French Guiana 2 by 2 on January 8 and January 25th by Illusion 76. Platform tests and the MEOP test on FM14 were carried out at S1b South over 7 days, and then the satellite was transferred to S3b in its own container to be filled with hydrazine. Integration of FM14 on the dispenser, which is the structure that holds the 4 satellites, took place on Saturday, February 10th. After their health checks, the 3 other satellites were then filled and integrated at the rate of 1 satellite every 3 days. The BTPOC review, which authorizes the transfer onto Fregat of the stack, that is, the dispenser with the 4 satellites, was held on Saturday, February 24th. The stack was assembled on Fregat by the NPOL team under Arianespace supervision on Monday, February 26th. Encapsulation and final preparation took place on Wednesday, February 28th, and Thursday, March the 1st.
From beginning of February, the Soyuz 3 stage was assembled and checked inside MIC in order to verify its readiness for launch. This 3 stage was transported in horizontal position from the MIC to the launch pad, where it was erected in vertical position and connected to the launch systems. The upper composite was vertically rolled out from O3b building to the launch pad, hoisted at plus 28 meters level and mated on top of the 3 stage.
After deconnection and reconnection tests on Fregat's umbilical lines, the customer carried out their satellite health checks on the launcher. Until the launch, the only customer activities were battery charging.
Yesterday, Fregat launch readiness automatic sequence was performed. In parallel, O3b satellite team conduct a launch countdown dress rehearsal and at least today begun a 10 hours final launch chronology. At first, automatic checks were performed at T0 minus was activated at T0 minus 5 hours and 10 minutes and the 3 stage at T0 minus 1 hour and 30 minutes.
So just to recap there, we have 2 synchronized sequences for Soyuz. The Fregat upper stage was triggered 5 hours and 10 minutes ago, as he said, and that entered its final phase at just around about 10 minutes ago. And the one for the 3-stage vehicle, the Soyuz, has entered its final phase now. It's called Kluchner Start. It was during that film at 5 minutes and 9 seconds. So that means that computers are running all the final operations at this point before the launch. And the teams who are overseeing those operations are here in the Soyuz Control Center, the Launch Control Center, as opposed to the Mission Control Center. So whereas mission controllers look at the whole mission, the launch controllers oversee everything to do with the launch itself. We have a number of teams working in here, and we have, of course, Russian and European teams working side by side, because, of course, Soyuz is a Russian launch vehicle. In Baikonur, the Launch Control Center is in several bunkers underground. And here, it's about a kilometer from the pad, in a specially protected building. That big grey mast that you can see there to the right of the launcher is the KZM, it's called. Inside it are all the feed lines, the umbilical lines connecting the vehicle and the upper stage, the satellites, to the teams on the ground. And those are being disconnected right now. This is the scheduled time. And a word about the ignition sequence. We throttle up the engines gradually. We switch the engines on 16 seconds before liftoff. We throttle them up gradually so that we can check that the engines are working correctly before pushing them to full thrust, which is, of course, when Soyuz leaves the pad. And when that happens, you'll see those 4 arms below. Can you see the blue arms? Can you see the yellow at the bottom of them? That yellow is a counterweight. Right now, the vehicle is suspended on those 4 arms. It's called the tulip. And at launch, they rotate away. Getting closer to the 1-minute mark, the range operations manager will call that out.
À tous EDDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
We are 1 minute to launch. We are orbiting the 4th batch of satellites in the O3b constellation, which Thales Alenia Space built for SES Networks. And we're flying on board the 18th Soyuz to launch from the Guiana Space Center. Our best wishes now to all the teams as we watch the launch.
Largage du mât KZM. À tous de DDO, attention pour la séquence finale lanceur. Top, H0 moins 20 secondes. Largage du mât VKM. Allumage du triétage. Attention. Top, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top, décollage. Deuxième étage du lanceur. Les moteurs des premier et deuxième étage fonctionnent normalement. Bonne stabilisation du lanceur. Le vol est nominal.
Beautiful pictures there in the clear blue sky above the Guiana Space Center, over the Amazon rainforest. Soyuz blazing a trail. Range Operations Manager is telling us that everything is going according to plan, everything's nominal.
Du premier et deuxième étage est nominal.
The propulsion of the first stage is nominal. Our altitude, bottom left, 36 kilometers above Earth. Our speed coming up to 2 kilometers per second. And you can see the boosters being jettisoned. See how they twist and turn. All part of the plan. We have confirmation there of separation, and we saw them. We don't need them anymore. The boosters can fall away. We're shedding weight. We're burning the core stage now. The Block A burns for nearly 5 minutes. Picking up in speed there on the right-hand side and climbing into space. Right now we are 78 kilometers high and getting closer to what we call the Kármán line. That's the border with space. It's named after the Hungarian-American aerospace engineer Theodor von Kármán, who died in 1963. And it's where the air becomes so thin that we can no longer support vehicles with wings, and we have to use rocket science to stay up. Look at the front of the vehicle there. That's the fairing, the nose, and in there are the satellites. It's protecting them from the rigors of the launch. Notably the acoustic vibrations. You can just imagine how loud it is. Everything's going according to plan. And also friction, because as we fly through the dense part of the atmosphere, it causes the outside of the fairing to heat up. But as we get closer to the Kármán line, the air becomes so thin that we hardly have any friction and we don't need the fairing anymore. So this is the scheduled moment where we lose it. It gets jettisoned. And we can see our satellites for the first time. Attached there on the front. And he's confirmed that the fairing has been jettisoned. Attached there at the front, the left-hand side, Some great images there from cameras on board a previous launch.
Le fonctionnement du moteur du bloc A est nominal.
He's telling us that the functioning of the Block A motor is going normally. So the 4 O3b spacecraft, lovingly built by the men and women at Thales Alenia Space, who are experts at this kind of thing. And if you look in the middle of the rocket, you can see a sort of latticework structure by the orange section. That is because Soyuz uses what's called a hot stage technique when it separates the stages, the second and third stage. The third stage engine switches on before
du bloc I, extinction du bloc A.
the second stage
Du bloc I et du bloc A.
switches off, and he's confirmed there that
Largage de
separation.
la section arrière du bloc I.
So you can see our tracking stations here. Galileo, that's at the Guiana Space Center. And then Natal, that's on the northeastern coast of Brazil. Then we have Ascension in the middle of the Atlantic. And we're heading across
Fonctionnement normal du bloc I.
the Atlantic. Takes a little bit of time for information to get from the launcher to us here at the CSG. Those stations send the information back here, but it has to go via Moscow first in order to be validated. So we're seeing all the key moments when they are scheduled to happen, but we get the actual confirmation from the range operations manager just a little later. That's perfectly normal. Good view there of the 4 satellites attached to the dispenser, or the special adapter, which is that cone in the middle. A cone is the wrong word, a tube. And all 4 of them attached in an array, like petals from this angle. It takes Soyuz just under 2.5 hours to deliver the satellites from liftoff.
This mission will comprise several steps, the first of which being the 3-stage Soyuz flight. The action of the boosters, the second stage, and finally the third stage shall position the Fregat to an altitude of 200 kilometers after 9 minutes. Then, following 3 Fregat boosts, the spacecraft will be put into the separation orbit. The first pair will be separated after 2 hours and the second pair 20 minutes later. In parallel, Fregat will perform 2 other boosts in order to join its disposal orbit, where it will end its life. This mission will be visible from our ground tracking stations: Galileo in French Guiana, Natal in Brazil, Ascension in the middle of the Atlantic, Libreville in Gabon, Malindi in Kenya, and South Point in Hawaii.
So those are the tracking stations picking us up as we fly over, and we are scheduled to pick up the signal during that film there in Natal. That's the one in Brazil. You can see it there on the right-hand side. The tracking stations are often known as downrange stations or ground stations. The information that they pick up from the launcher tells us how the flight is progressing in real time, and it allows the experts to work out if things are going according to plan. And it also enables them to make an assessment after the flight and check how things went. It's called telemetry. It comes from the Greek. Tele, of course, means remote, and metron means measure. Everything's going normally. These computer-generated images are a simulation of what the experts have calculated is happening to the launcher and the satellites. The teams plan a very precise schedule of events, which is based on extremely accurate predictions for the flight, and they put all that information into the computer. These images are then a simulation of those predictions. So every movement and every position that you see is a simulation of exactly what's been planned for the flight.
Le déroulement du vol est nominal.
He's telling us that everything's going according to plan. You can see there, this is the scheduled moment for the third stage to shut down its engine. We're really starting the next phase now of the journey. The upper stage is taking the wheel. It's called Fregat. And it's the intelligent part, the powered stage of the flight.
Du bloc I, séparation de l'étage Fregat.
Is over, and that's been confirmed. And Fregat has the rather more subtle job of delivering the satellites to a specific orbit and separating them. You can see on the top right is our trajectory. That's the planned trajectory, and the white cross is the actual position of the launch vehicle. Right now, Fregat's getting ready to switch its engine on for the first ignition. There it goes. This is the scheduled moment. It's going to burn for just under 4 minutes. Fregat is that gold structure. You could see it back there. On the right of the screen, you can see it is made up of 6 spherical tanks, which are organized in a circle. 4 of those are...
Tous les systèmes bord fonctionnent nominalement.
He's telling everything's working fine on board. 4 of those are for propellants and 2 for avionics. That's the sort of thing you find in the cockpit of a plane. Flight control systems, navigation, communications, that kind of thing. And Fregat was originally designed as an interplanetary probe. It was adapted to fly on board Soyuz, and it can switch its engine on and off up to 20 times. So it can take its passengers pretty well anywhere they need to go. And that makes Soyuz ideal for launching constellations like today. And of course, with all 3 rockets here at the Guiana Space Center, Arianespace can launch any satellite to any orbit. And this was 12 minutes ago. Superb liftoff there. From the Soyuz launch zone near Sinnamary. Today, Fregat is scheduled to perform 3 burns before separating the satellites. This is the first one. Takes us to a transfer orbit. Then we have a coast phase. The third burn will take us to the separation orbit. That's where we'll start releasing the satellites. On the right-hand side of the screen, you can see that whereas before we were using all our power to get away from Earth, our curve has plateaued out a bit. He's telling us that we're picking up the signal there at the Ascension Island tracking station, which is a volcanic outcrop in the middle of the Atlantic. Used to be a stopover during the early days of commercial airlines. And NASA had a communications dish there during the space race, I believe, in the mid-1900s. And I think that it was used to track the Apollos. So that means we are powering our way across the pond, across the Atlantic, towards the west coast of Africa. So, yes, on the top right-hand side of the screen, we were using our power to really pull ourselves away from gravity. Now we're using it to really pick up speed, and so that we can climb higher and higher later in the flight. You can see the bottom right of the screen, our speed is above 7 kilometers per second. This is our scheduled time for the frigate upper stage to switch its engine off. The onboard computer sends the command when it knows that the upper stage is in the right orientation, at the right speed, at the right altitude, that sort of thing. So we're now in what we call a ballistic phase. This is going to last for about 8.5 minutes, and it means that we're traveling without propulsion. We're traveling high enough and fast enough to cruise without the engine. It certainly saves on propellant, and it's important because it optimizes the conditions of the flight. This is the first of 2 coast phases. The second one will last just over an hour and 20 minutes, and that one will get us closer. The O3b constellation has so far consisted of 12 satellites.
Welcome to Kourou for VS18, the first Soyuz launch of the year from the Guiana Space Center. Following the successful launches of the first 12 O3b satellites, the Soyuz ST-B launch vehicle will deliver into medium Earth orbit the next 4 O3b spacecraft. The fleet of O3b satellites orbits the Earth in a circular equatorial orbit at an altitude around 8,000 kilometers. It provides mobile phone and internet connection at fiber optic speeds. The O3b satellites have been built by Thales Arianespace for SOS. Though very similar to the previous ones, those new 4 satellites, each weighing 700 kilograms, have been slightly modified to increase their performance, thus enabling SOS to offer more capacity and a greater reliability. We would like to thank TAS team for the great job that we have carried out together throughout this program, and of course SOS for the continued confidence they put in Arianespace and its fleet of launch vehicles, and we look forward to seeing you soon for the launch of the next 4 satellites dedicated to this constellation.
Indeed, and SES will be launching another 4 O3b satellites with Arianespace. That's going to be in 2019, and that'll bring the constellation up to 20. SES is a world-leading satellite operator. They have more than 50 satellites in geostationary Earth orbit and, of course, soon to be 16 in medium Earth orbit, the O3bs. And they have an impressive portfolio that includes the Astra satellite system. You may be familiar with that. O3b is, I believe, the fastest growing and most successful satellite startup. And by adding 4 more satellites to its 12-strong fleet, SES is adding 38% more capacity across the globe, so that's a lot. Originally, O3b was designed to bring high-speed and affordable internet from space to the other 3 billion people who didn't have it. Of course, the population has grown since then. But it's been so popular that it's ended up with other clients too, like cruise ships, etc. And they've got some very happy customers.
The value of our work starts with helping people connect with each other, helping businesses connect with new customers, helping organizations connect with innovation. But ultimately, this work isn't just about connectivity. It's about enabling the world to achieve great things.
O3b allow us to increase the throughput per user, which allow a better quality of experience.
Especially this year, I've seen a very large difference in the speed and the quality of the internet that we've been getting from T-Mobile Telecom. It's improved the efficiency of the organization. It's also improved the efficiency of our teams because they can spend more time actually delivering services and less time doing administrative tasks.
And it means something different, not only for the guest that's on board, but it means something really different for my company, for Royal Caribbean. It allows us to attract a new type of guest.
Et avec l'ensemble de l'équipe pré-service, on avait vécu une expérience très élevante parce que jusqu'à là, on savait que le niveau de la qualité de service annoncé par O3b, on ne peut l'avoir qu'à travers la fibre optique. On a compris quand même que finalement, ce qui a été raconté jusqu'à là, ce qui a été vraiment montré jusqu'à là à travers le programme, c'est une réalité.
It's something big. So we are talking about not only improving the user experience, we are talking about changing the user experience and giving to the user some new things.
With our O3b fleet, we have something that's genuinely unique. We're the first and only operator of a non-geostationary constellation, and what that brings to our customers is a level of performance that is highly differentiated from anything else. We can do things, and our customers can do things across our O3b fleet that they just can't do across any other satellite solution.
To experience, to achieve, to enable great things. Our definition of greatness means working closely with our customers to empower their users with the high-performance service they need to accomplish great things. And with the new capabilities we're adding to the O3b fleet, SES Networks' drive for greatness can now enable even more customers to grow anywhere they may be.
"21 minutes and 22 seconds into the flight. During that film, the range operations manager confirmed that we picked up the signal at the tracking station in Libreville, which is in Gabon. So we're flying out over Africa. Libreville is the capital of Gabon, which is in western Central Africa. It's a port city on the Como River near the Gulf of Guinea. And I believe that the tracking station has been there since 1994. My understanding is that the German Space Agency set it up as a mobile tracking station so it could be moved to other areas. But it's proved to be so useful that it's remained in Gabon as a permanent station. And the teams there are tracking us right now. You can see on the top right-hand side we're going to soon start really climbing into space, so you can keep your eye on our altitude. Down at the bottom left there, you'll see we'll be going up and up. Frigate upper stage is getting ready to switch its engine on now for the second pre-burn phase. Basically, it puts its foot on the accelerator and gives a burst of thrust to push the fluids back into the tanks. And here we have the scheduled ignition, the second ignition, which lasts for 8.5 minutes, roughly. I have to say, O3b is a very pioneering project. As I said earlier, its aim is to provide affordable, high-speed internet from space to billions of people who are presently unconnected. And I think it's fair to say that we often take broadband for granted. But actually, it is a privilege. And now that privilege is extending around the equatorial part of the globe, thanks to the O3b satellites. And of course, Arianespace is delighted to play its part in helping to reduce that digital divide. It's launching all of the satellites in the constellation. So how does O3b do it? The satellites, how do they do it? Well, a bit of history. O3b came from a big idea originally when the founders were trying to lay cables in Rwanda to connect schools, I believe, to the internet. And they found it very challenging. and they decided it would be better to connect using satellites. However, most telecom satellites are in geostationary orbit, and for anybody who's unfamiliar with this, we have three types of orbit. We have low Earth orbit, we have medium Earth orbit, and we have geostationary orbit. And geostationary orbit is 36,000 kilometers above Earth. And anybody who has used a satellite phone will know that it takes a few seconds for the signal to travel 36,000 kilometers into space and back again. And that delay is called latency. So the O3b founders decided to put their satellites closer to Earth, in medium Earth orbit, around 8,000 kilometers. That's about 4 times closer to Earth than the geostationary satellites. And that way they were able to reduce the delay. So that's why the O3b satellites are often thought of as fiber from space, because they give customers that low latency connectivity, which is similar to the kinds of speeds that you get from fiber on Earth. So when the teams decided they wanted to connect all these billions of people,
l'allumage du moteur principal Fregat pour le deuxième boost.
Getting ready there to switch the engine on for the next boost. So they decided they needed an industrial partner, and that partner is Thales Alenia Space. The men and women at Thales Alenia Space are very experienced at building constellations. And they drew on that know-how to create innovative technology for O3b. And they too had to think outside the box when they designed the spacecraft. For this latest batch, they've increased the performance. Here is the CEO.
When the first batch of O3b satellites lifted off in 2013, it was a decisive moment. It was the beginning of a new era in space. It opened the way to constellations in medium and low Earth orbit dedicated to high-speed broadband. It opened the way to fiber in the sky. At Thales Alenia Space, we supported O3b's exciting initiative from the very beginning. Now, here we are 5 years after that first launch, sending this fourth batch into orbit to feed the constellation, making scalability a reality. These 4 new satellites will provide even more capacity and flexibility to O3b's customers. At Thales Alenia Space, we are very proud of our outstanding partnership with O3b, and we value the special relationship we have developed over the years. Today is important for all of us, and especially for SES Networks, who are continually expanding their business. We are fully committed to helping make this constellation a great success. Our congratulations to all the teams, and our warmest thanks to SES for the trust in Thales Alenia Space.
And after today, Arianespace will have launched 154 satellites built by Thales Alenia Space, and there are 11 others in the order book. During that film, we were scheduled to pick up the signal at the tracking station in Malindi, in Kenya, on the east coast of Africa. So we're heading out now over the Indian Ocean, and our flight path takes us towards Southeast Asia. So we should be flying over the Seychelles and the Maldives, those beautiful jewels in the Indian Ocean, out across Indonesia, Papua New Guinea, and across the South Pacific, back towards the west coast of South America. We will have done a full lap of the Earth in a without the engine. Interesting word, ballistics. We often hear it. It's actually the science